Okay, so we're going to have double angle formulas is what they're called. By the way, a lot of textbooks refer to these not as formulas but identities. And the ones that we're going over, like the fundamental identities and some of these formulas, a lot of these formulas, they'll put them in the cover of a textbook, like a calculus textbook will have, like on the back cover or the front cover, a list of these identities, okay? A lot of the textbooks do that. Okay, so for the double angle formulas, this is what we have. There's 3 of them, and so I'll just show you where they come from. So we know sine alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. And what we do is we say, well, what if we had sine of theta plus theta? So the angles were the same. Well, then that would give us sine theta cosine, oops, that's not a theta. Sine theta cosine theta plus cosine theta sine theta. But isn't this really just sine theta cosine theta? And so now we have 2 of them. And so we get the sine of 2 theta, theta plus theta, 2 theta equals, and then there's 1, 2 of these, 2 sine theta cosine theta. And so that's the formula. It's called the double angle formula, and that's what it looks like. Okay, so now we'll do it for cosine. So say we have, our addition for cosine, and that is cosine alpha cosine beta minus sine alpha sine, that's not an alpha, sine alpha sine beta. So when we replace those angles with the same angle, so theta plus theta, we're going to get cosine theta cosine theta minus sine theta sine theta. And so that's going to mean cosine of 2 theta is equal to, now cosine theta times cosine theta, that's cosine squared theta, minus sine squared theta. Okay? So remember that one. And we'll come back to that one in a minute. And then for tangent, we have a formula for tangent alpha plus beta, which is tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. And so that if we say, well, what if the angles were the same? So double angle idea, theta plus theta, then we would have tangent theta plus tangent theta over 1 minus tangent theta tangent theta. And so then that's going to be, scroll up, tangent 2 theta would equal, in the numerator we have 2 tangent theta over 1 minus, and then that's going to be tangent squared theta. So this shows you where they come from. I don't know if I put a box around the cosine one, but those are our double angle formulas. And I said we'd come back to the cosine one anyway. So it's good to see the notation and how they're thinking, where these come from. And we'll show you how to use them. Again, you might not have them memorized. Usually the double angle ones, I don't do too bad memorizing those. But that's me personally. But you can have a sheet of identities to help you, or formulas to help you with that. Now back to the cosine. So cosine 2 theta is equal to cosine squared theta minus sine squared theta. But we know some things about cosine squared theta and sine squared theta because of the Pythagorean identity that we have. We know sine squared theta plus cosine squared theta is equal to 1. We also know cosine squared theta is equal to 1 minus sine squared theta. Now, using that idea then, we could replace the cosine squared. So we would have 1 minus sine squared theta for the cosine squared theta, and then we have this other minus sine squared theta. That gives us then an alternate form, 1 minus 2 sine squared theta. So you could use a double angle formula for cosine and get it in terms of just sine. And sometimes that's useful to us. So this is just, let me erase my big arrow there. This is just another form of the double angle formula, but it's handy to be familiar with it, so I will put a box around that one. So you might say, well, why didn't you replace the sine squared? You could do that as well. So going back up to this one here, if I replaced the sine squared theta, so think about your sine squared theta plus cosine squared theta equaling 1. And if I'm solving for sine squared, I'd have sine squared theta equals 1 minus cosine squared theta. And so then if I replace the sine squared, it would be minus 1 minus cosine squared theta. And then if I do some algebra, cosine squared theta minus 1 plus cosine squared theta. And I get another alternate form that's going to say cosine of 2 theta is equal to 2 cosine squared theta minus 1. So these alternate forms are sometimes used. So you have it in terms of sine, and here you have it just in terms of cosine. The first one had both the cosine and sine, so this one right here. Okay, so there's kind of like 3 of them for cosine 2 theta. Now, you might have a question about this last one, like what's the big deal? Here we have cosine, and on the other side we have cosine. But this is a cosine of 2 theta. This is just a cosine of theta. It's squared, but it's the angle you're using. Okay, so that's where these come into play. We'll show you how to use them.